Hello, my name's Chelsea and this video is part of a series of A-level content that is all about learning differentiation. The image of the worksheet in this video, as well as other maths related content, is over on my Instagram page because I love me some numbers. Okay, you all know the YouTube drill now. This content is free from me to you. Therefore, it'd mean a lot to me if you hit that like button, press subscribe and wait for it, go follow me on Instagram, just so I know that maybe this is quite useful and I should continue doing it. Thanks for watching.
Alright then, this is the second worksheet on the topic of differentiation in the A-level series. A link to all of the videos on this series is given in the description box below. And this worksheet is going to be all about tangent lines. Okay, let's begin with talking about gradients again. God, we all love gradients. So you may or may not have been taught this, but one way that I use to visualize gradients of a certain curve is by using pencils. So for instance, if I wanted to visualize how the gradient of this curve changes as I go along it, I can pick a point on the curve whose gradient I want to know about, and I can take a pencil and place my pencil roughly parallel to the curve at that point. So for instance, if I took the point here where my cursor is and I want to know the gradient there, I would get a pencil and place it roughly parallel to the curve's direction at that point, and I would get a pencil like this. And what the pencil does is it can tell you two things. It can tell you the sign of the gradient, i.e. whether it's positive or negative, and also it can tell you the magnitude of the gradient relative to other points that you might look at. So for this point here, I can see that the gradient is positive because the pencil is increasing from left to right. And I can also look at it and go, well, that pencil is near vertical. So I would say that the magnitude of that gradient is pretty big. On the other hand, if I was to say pick this point on the curve, I would get a pencil and place it roughly parallel to the curve at that point. And here we can see that this pencil is slightly shallower. It's like not as steep as this pencil here. So this is telling us that the gradient at this point on the curve is a bit smaller than the gradient at this point on the curve because the pencil isn't as steep. And also it shows us that the gradient at this point is still positive. Now, if we were to take this point here, the pencil is actually going in the opposite direction. So it's decreasing from left to right. This tells us it has a negative gradient. So this point on the curve will have a negative gradient. And then finally, if we were to pick a point like this on the curve, our pencil would look something like this, which is pretty much horizontal. And this tells us that the gradient is 0. There is no gradient at this point. This will be called a stationary point later down the lines in the worksheets to come. So yeah, we can use pencils to see how the gradient of a curve changes as we travel along that curve. Now, using pencils to visualize gradients is brilliant, but it's not totally accurate. We can't actually get a pencil to be perfectly parallel to a certain point that we're looking at, maybe unless we zoomed in like really close up, then we could. But that's okay. What the pencils are doing is really key. Okay, they might not be perfectly parallel, but they're showing us that if we were parallel, we'd be able to find the gradient at all points along the curve. i.e. if we were to get a straight line and make it parallel to a point along the curve, we could work out the gradient of that straight line and therefore figure out what the gradient of the curve is at that point, because we know that lines that are parallel to one another have the same gradient. So actually, this curve here, if we were to split it up into lots of tiny straight lines, we could actually find the gradient of all points along this curve because we easily know how to find the gradient of a straight line. And I keep talking about straight lines, but actually there is a name for them. And these straight lines that are parallel to points on the curve are called tangent lines. So let's look into these. So a tangent is a straight line that touches a curve at a point P and has the same gradient of the curve at point P. So here in this diagram, we've got a curve given in black. We've got a tangent line here, and the tangent touches or meets, however you want to say it, the curve at this point P. and a tangent line is always parallel to the curve at this point P. So you know at point P, the tangent will have the same gradient as the curve at point P. We can use this knowledge about tangents and we can see how it links to differentiation, how differentiation was first derived. Remember, differentiation is the act of taking a function and finding its derivative. And its derivative tells you the gradient of a curve at every point along that curve. Well, how could you find the gradient of every point along this curve? Well, what you could do, you could take every point along that curve and plot a tangent line through it, and therefore you could find the gradient at every point along that curve, because you have tangent lines going through all those points, and tangent lines are just straight lines whose gradients are really easily found. And that's essentially what the act of differentiation does. It finds the gradient of a curve at all points by drawing tiny tangent lines through all those points. Let's look at some examples to really cement this idea in your mind. So the line y equals 4x minus 7 is tangent to the curve y equals f of x, some curve, we don't know what it is, at a point 2, 1. And it's shown in this graph here. So black is y equals f of x is the curve, and then the tangent line is this dotted line here, and the point where the tangent line and the curve meet is 2, 1. And the question asks, can you find the gradient of the curve y equals f of x at x is equal to 2? So we want to find the gradient of this curve at x is equal to 2, which is here. As with every question in maths, all your information is there in the question, so let's use it. We want to know the gradient of the curve at point x is equal to 2. What do we know about this point? We know that a tangent line with equation y equals 4x minus 7 passes through this point and is tangent to this curve. That means that y equals 4x minus 7 must have the same gradient as the curve at this point. So if we find the gradient of this tangent line, then we've practically found the gradient of the curve at that point. So here we go. Y equals 4x minus 7 is a straight line, so it must have gradient 4, because we know that straight lines come in equations of the form y is equal to mx plus c, where m is the gradient. Okay, we also know that line is tangent to the curve at point 2, 1. This means that the gradient of the curve at x is equal to 2 is the same as the gradient of y equals 4x minus 7 at x is equal to 2. Well, the gradient of the tangent line is 4 no matter what point. Therefore, the gradient of the curve at x is equal to 2 is 4, i.e. f dash of 2 is equal to 4. Second example, find the tangent to f of x equals x squared at the point minus 1 minus 2. First things first, if you want to find a tangent line, you know that that tangent line is a straight line equation, so it's going to look like y is equal to mx plus c. We need to find the m and we need to find the c. Let's first find the m. You know from the definition of tangent lines that at the point minus 1 and minus 2, the tangent line will have the same gradient as the curve. So if we find the gradient of the curve at this point, we found the gradient of the tangent line at this point. How do we find the gradient of the curve? We differentiate. So if f of x is equal to x squared, then f dash of x, its derivative, is equal to 2x. At the point x is equal to minus 1, the derivative becomes minus 2. So that is the gradient of the curve at point minus 1 and minus 2. The tangent has the same gradient as the curve at this point, i.e. this m must be equal to minus 2. So the tangent so far is y is equal to minus 2x plus c. We just have to find c now. Since the tangent line passes through the point minus 1, 2, these values of x and y, i.e. x is equal to minus 1 and y is equal to minus 2, are solutions to the tangent equation, i.e. we can substitute these values of x and y into this equation and therefore find the value of c. And that's what I've done here. I've substituted those values and I get c is equal to minus 4. Therefore, the tangent is y is equal to minus 2x minus 4. As always, I've put some questions together down here so you can test your knowledge. The solutions to these questions are given on my Instagram page. There's a link to this in the description box below. Thanks for listening.